we're going to take our last little look at our chemistry review from Science 10. So, let's take a look at chemical amount. Now, chemical amount is another fancy way of saying moles. So, chemical amount, we talk about that in terms of moles. So, we know that we can calculate chemical amount through our reaction, or through our equation, moles, which is little n, equals mass over molar mass. Okay, so that's the equation we've dealt with so far as we've gone through calculating our chemical amount. Now, we also need to remember how to calculate molar mass. We need to know how to calculate moles from that molar mass, as well as we should probably be pretty familiar with calculating our mass from our molar mass and mole values. All right, we also talked about Avogadro's number in Science 10, which is essentially looking at the number of molecules or particles in 1 mole. So it's number of particles, okay, and particles is a general term, per mole. Now, there's a little video I want you to watch about Avogadro's number to give it a little bit of sense, or make sense of that number and give it meaning to you at the end of this lesson, and that will be linked into the workspace following this lesson as well. So let's just take a look at some review on calculating molar mass and moles and mass. So for this lesson, you should definitely have your periodic table out. You will for sure need your periodic table for your atomic mass values or atomic molar mass values, and you should also have a calculator out to do some simple calculations as we go through. So calculating molar mass, how do I do that? I'm going to split this sort of into 2 examples. I'm going to start with calculating my NaCl. Now, essentially to calculate NaCl, I have 1 atom of each in this component, so in this compound. So what I like to do is I like to write down that I have sodium and chlorine, and I write down my 2 elements that I have existing in this compound. Then I write down how many of each I have. I have 1 times my sodium, and I have 1 times my chlorine. Now when I take a look at my periodic table, which I can jump over to really quick here. All right, zoom out a little bit. I see that my sodium has a 22.99, okay, over here on the left-hand side, 22.99 atomic molar mass, and my chlorine has a 35.45 atomic molar mass in my periodic table. So when I jump back, I'm going to just jot these values down here. Our unit is grams per mole. So when you think about the unit grams per mole, that is literally how many grams 1 mole is. So if you were to weigh out 1 mole of sodium, it would be 22.99 grams. Same with chlorine. If you were to weigh out 1 mole of chlorine, it would be 35.45 grams. So this equals 22.99, and this equals 35.45. So then I'm just going to get a total on those 2 values. So if I either type them into my calculator or do my math through addition there, okay, I will get that this equals, let's just do this in a new color, 5 plus 9 is 4, carry the 1, 4. All right, and then I would get 8, 5. Okay. So I get 58.44 grams per mole. All right, so that's my sodium chloride. Similarly, let's take a look at my next example, which is my iron 3 oxide. Now in this case, I write down again my elements that I have here. I have iron and I have oxygen. And I have 2 times my iron, and I have 3 times my oxygen values. So when I jump back to my periodic table, or if you have your periodic table out and you're taking a look at it, my iron mass is 55.85 atomic mass, and my oxygen is 16.00. And these are, again, grams per mole. Now, when I multiply each of these values by their coefficients, this guy equals 111.70 grams per mole. And this guy here, 16 times 3, of course, is 48. And when I do my addition here, I get that my value for my molar mass is 159.70 grams per mole. All right, so simply I just add up each component of my compound as an element, how many of each atom do I have, and then I can add them all together. Let's maybe take a look at one more complex example. I'll jot it down kind of below here. Let's take a look at, what's a great example? We'll do calcium phosphate. Okay, let's take a look at this example. This is a little bit more complex. I have calcium, I have phosphorus, and I have oxygen. I have three elements to account for here. Now I have 3 calciums, I have 2 phosphorus, don't forget that I have to multiply this 2 in, and I have 8 oxygens. So calcium has an atomic molar mass of 40.08. Phosphorus has an atomic molar mass of 30.97. And oxygen again is 16.00. So 3 times 40.08 is 120.24. Okay, 2 times 30.97 is equal to 61.94. And 8 times 16.00 is equal to 128. Now when I add all of those up together, so I have 128 plus 61.94 plus 120.24, that gives me a value of 310.18 grams per mole. Again, I have to account for all atoms involved in this compound, and I have to multiply those values by how many atoms there are of each. All right, so now that we know how to calculate molar mass, let's take a look at how to calculate moles. So we'll take a look at these 2 examples here. Now we have to remember that we're using our mole formula, which is moles, which equals mass over molar mass. All right, so when we take a look at our moles, I always like to jot down my formula on the side. So, oops. Just so I have it handy and fresh in my mind as to what I'm doing. I also always like to write down the variables that I'm given. So I have 4.5 grams of H2O. So I'm going to write down my variables. I have my mass, which equals 4.5 grams, and I have my molar mass. I might need to do a calculation, but I will get my molar mass. So my molar mass of H2O, all right, H2O is equal to 2 times my hydrogen, and my hydrogen is 1.01 grams per mole, and I have 1 times my oxygen, which is 16.00 grams per mole. So this equals 2.02, and this equals 16.00. which gives me 18.02 grams per mole. Okay, so I can write that value in, 18.02 grams per mole. My moles equals my mass over my molar mass, so when I plug that into my formula here, I get 4.5 grams divided by 18.02 grams per mole, giving me an answer of 0.2497. So I'm just going to round that to 0.25. That would be appropriate significant digits. 0.25, moles. That's my unit. Now again, because I have my grams here and here, that cancels out. My moles flips over to the top of my equation, giving me my unit in moles. Okay, so that's how I would solve that one. Let's take a look at our next example here. Okay, we have 0.12 kilograms of NaOH. So let's again write moles equals mass over molar mass. I have my, let's see what color, okay. I have my mass equals 0.12 kilograms, 0.12 kilograms. And my molar mass, I'm probably going to have to do a calculation for. Okay, and also because my units are in kilograms, I should convert this into grams. So I go 1, 2, 3 places over, so this is equal to 120 grams. Okay, my molar mass of NaOH, again, if I take a look, I have 1 Na, so I have 1 times my 22.99. If you don't know where I'm getting these numbers from, they're just from your periodic table, so you can take a look at that. So 1 times my oxygen, which is 16.00, and 1 times my 1.01. When I total this, looks like it should equal 40.00 grams per mole. So my molar mass is equal to 40.00 grams per mole. Plug this into my equation up here, and I will plug in 120 grams divided by 40 grams per mole. And conveniently enough, that should give me an exact number of 3.0 moles. Okay, again, my units cancel out, grams and grams cancels, giving me moles as my unit for my answer. Okay, so that's the way that we calculate our moles from our molar mass and a mass value. Now, one last calculation, we can calculate our mass. Again, this is just rearranging our formula in a different way to calculate our mass. So we start out with our formula as moles equals mass over molar mass. Okay, and some of you may be familiar with this triangle. You might have been introduced to the triangle. And again, anything that is a horizontal line here, that is a divide sign, and anything that's a vertical line is a multiplication sign. So if you cover up your answer here, so if I'm looking for my mass is what I'm solving for, it'd be moles times molar mass. However, I don't like the triangle 100%. I prefer to do it the mathematical way. So because I'm dividing by my molar mass here, I need to multiply it to cancel that out. So in order to get my mass alone, I need to continue my, if I multiply my molar mass on the bottom here, I need to multiply my molar mass to the other side, which gives me moles times molar mass. So in this equation, I then write down my formula, mass equals moles times molar mass, and it's giving me values in moles. So my moles is equal to 0.15 moles of potassium phosphate. So I again have my molar mass. I just need to do a little first calculation here. So I have 3 times my molar mass of potassium, which is 39.10. Okay, I have 1 times my phosphorus, which is 30 0.97. And I have 4 times my 16.00. Okay, so 3 times 39.10 gives me 117.30, and 4 times 16 should give me 64.00. So when I add these all up together, I get a total of 212.27 grams per mole. Plug that right into here, so 212.27 Okay, so when I go to plug this into my formula, I have my moles times my molar mass, so I have my 0.15 moles. Multiply that by my molar mass, which is 212.27 grams per mole. And that will give me an answer of 31.8 grams. Okay, so again, this is just rearranging this formula to solve for an unknown variable. In this case was mass. So that is it to calculate chemical amount. There is a little worksheet that will have you calculate mass, moles, and molar mass, and I would suggest making sure you're fully confident with this content prior to doing that assignment. Good luck!